we started on Friday, which is kind of the same thing as finding the zeros of a function. We're just not drawing a graph here, we're getting our solutions. But I talked to you about how P's and Q's are great, but it's time consuming, so it's probably not ever going to be your first option. It's not what you would choose to do to solve a problem. You do that as a last resort. So if factoring techniques are possible, that's where you want to start. It'll be way faster to get there. If I look at this one, is it possible to solve this with factoring? Yeah. Would this one be possible to do P's and Q's?
Yeah.
What's the P represent? The constant. Do we have a constant term on this one?
No.
No. So that would pose a problem for us if we tried to go that route. But if I wanted to factor, what did you start out by doing?
X squared.
Mm-hmm. We'll do this x squared minus x minus 6. So that factors into x minus 3, x plus 2. So the zeros would be what?
0 equals 2, 3, 2.
You may not have called it zeros, you might have just said the solutions, x equals those, that's fine because I told you to solve it. But in terms of our graph, we know those are the places where you hit the x-axis. What's going to happen at the 0? Our graph will bounce because of that square. At the negative 2 and 3, it will just go through. What is the y-intercept of this graph? If you put in 0 for your x, you get 0. What is our end behavior? Our degree is 4. Remember, even degrees look like a parabola unless it's a negative coefficient and it flips. So it should start up here. Hit it negative 2 and go through, hit it 0 and bounce, hit it 3 and go through. So our graph looks something like that. The last two, those were the only two parts I had you guys do, but now I want to use this graph to answer a couple questions. Where is this graph greater than 0? Good. Where is this graph less than 0? Is it? Why do we have to break at 0? Right, it bounces there. Now, if I had said less than or equal to 0, then you could have said negative 2 to 3. But when the x is 0, the y is 0, so if I don't have an equal to, we have to separate our interval there. Is that one okay? Let's try another one. Okay. What would I do first on this one?
Distribute the x.
Then what?
Subtract 2x squared plus 7 over 2x cubed.
Right, we need it to be equal to 0 if we're going to solve. So we'll bring everything over to the left-hand side. So we have our 3x cubed, will be a negative 2x squared, a negative 27x, so a positive 18. Okay, do we have a greatest common factor? No, nothing comes out of all of these. So what else can we do? Remember with grouping, we want two parentheses that we can factor something out of, but you cannot add a parenthesis after a negative. So first I need to make this a plus negative 27. Then I can put the first two in a parenthesis and the second two. So the first parenthesis we can take out an x squared. We have a 3x minus 2 left. Second parenthesis, what can we take out? We have 3x minus 2. And remember, grouping works if the parenthesis is the same on both. So this was a success. So now we factor out that parenthesis. And so if I take out the 3x minus 2, we're left with x squared minus 9. How does x squared minus 9 factor?
X plus 3x minus 2.
So my solutions would be x equals 2/3, negative 3, and positive 3. And how could I have known from the very beginning that I should get 3 solutions?
Because the degree is 3.
The degree is 3, so we need 3 solutions here. Alright, so if I want to graph it, some important pieces of information. What's the end behavior of this graph going to be? Down, up. It's a cube, so the ends are going opposite direction. Positive coefficient, so looks like normal. We have our zeros already. Will it go through or bounce? Through all. Y-intercept. If you put in 0 for all of our x's, let's go like maybe even in our factored form might be the easiest place to look. If I put in 0, we would have a negative 2 times 3 times negative 3, and we get 18. Positive 3, hit the y-axis at 18. Start down here and up here. Through all of our zeros. So something like that. So our main goal on these is the factoring, but I'm trying to throw in the graphing piece just as a refresher because we are winding down on this chapter. Any questions on that? I don't want. Look at this. Do we have a greatest common factor? No, I don't have enough terms for grouping. What could we do? Yeah, we could think of like triquadratic formula. We could even just see if it factored nicely before jumping to the quadratic formula, but treat it like a quadratic. So if we're trying to break it into these, and we know it's like a quadratic because you have an x to the fourth, half of that is x squared, and then we have a constant. So what would x to the fourth break into for each parenthesis? So that's why we know it's like a quadratic, because that's what our middle term is. Okay, what multiplies to negative 40 and adds to negative 6?
10,
Mm-hmm. Negative 10, positive 4. Okay, so now if I want to solve, I could set each of those equal to 0. So x squared equals 10, square root, so x is plus or minus the square root of 10. We set x squared plus 4 equal to 0. What do we get?
So it's, 2.
Just 2? I, because you would have the square root of negative 4. So it was degree 4, we got 4 zeros. Positive radical 10, negative radical 10, positive 2i, negative 2i. If I asked you to graph it, you would kind of have to estimate a little bit here. What's our end behavior, first of all? It's an even power, so it looks like a quadratic, positive coefficient, so both ends are pointing up. So our end behavior is up, up. Will it go through or bounce at my zeros? Through all of them, because they all have a degree of 1. What is our y-intercept? So if we try to graph, we would have to approximate the square root of 10. So you could use your calculator and get a decimal approximation. So it's just a little bit past 3. And then the negative square root of 10 would be like a negative 3.1. Can we graph the positive and negative 2i? No. So we know both ends are pointing up. Even though it's degree 4, we're only hitting the x-axis twice because the other zeros were imaginary. So it looks something like that. So where is this graph greater than 0?
Infinity to the square root of negative 10.
The negative square root
Negative
of
square
10.
root of 10.
Union.
Square root of 10 to positive infinity.
Good. I didn't ask it, but if I did, where is it less than 0?
Negative square root of 10 to positive square root of 10.
Perfect. Any questions on those? I want you guys to solve this one. Let's get them all on the same side. So it's equal to 0. We subtract this over. Now we have two terms. If I want you to solve this by factoring, what can we factor out?
X squared.
And that would leave us with, so now, how do you factor x squared minus 36?
X plus 6, x plus 6.
So our solutions would be what?
0 is plus 2 and 6.
I didn't ask for a graph, but if we wanted to do it for practice, we would hit at 0. What's going to happen at 0? At positive and negative 6? Through. Are you guys feeling pretty confident on the graphs? We know both ends. What would our end behavior be? The y-intercept, if you plug in 0 for all of your x's. So we start here. We go through, hit at 0, bounce, get positive 6, so something like that. Alright. Are there any questions for me? So, here's kind of our game plan. I'm done with this section now. There's a math Excel assignment open. We have been, if you watched what I was writing on the board, we're going to have a test Thursday. So that leaves us Tuesday and Wednesday as review days. So I'm probably going to do a couple different review things. We'll have our study guide like always, but I might do just another little emphasis on the graphs. The quizzes, not necessarily your all's class, but they weren't amazing. So I might take a little bit of time to make sure we hit a couple of pieces from that before we go into our test. So that's kind of the game plan.